You're much welcome at Naftali Homes and Medical Sciences. In this session, we are going to take you through Introduction in Chromatography, which is a physical technique used in clinical medicine, in pharmaceutical industries, in food processing industries, and also in forensic medicine to separate and identify components. And as we begin, we request you to subscribe if you haven't, like the video and share to many others. And we are beginning with, we want to see the definition, what is chromatography? Then we shall also look at the application, that is general application in different faculties, that is in pharmaceutical, in clinical medicine and other components. Then we shall look at the components, general components of chromatography. Then we look at classification, and we end with some terminologies used in chromatography. So by definition, chromatography is a physical technique. It is a physical technique, and this technique is used to separate components, or compounds in a sample mixture. So we have to have a sample mixture. This sample is containing different compounds or analytes, which we want to separate and identify. And here we identify it by passing the mobile phase. By passing the mobile phase through the stationary phase. So this is the way we can easily define chromatography. You have the sample mixture, then this sample mixture is mixed, or it is put in a solvent or a gas known as the mobile phase, and it is passed through the stationary phase. And as this mobile phase containing the sample mixture is passing through the stationary phase, the difference in interaction of compounds in the sample mixture in a stationary phase will enable us to separate these components so that we can purify them and quantify. And we shall look at different mechanisms how solutes interact with the stationary phase and how we are able to classify depending on their interaction. So we are seeing the application of this chromatography, or the use, maybe we can call it purpose or use. It is being used, one, to separate compounds in a sample mixture. We are using it to purify. We are using it to identify. That is identification, to identify, and lastly to quantify. So these are the major uses. When we have a sample mixture containing different components or analytes, we are able to separate, to purify, identify, maybe this is compound A or B or C, and then we can even go ahead and quantify. We tell you how much is it in this sample. If it is an impurities, how much impurities are in this drug, or how much impurities are in the herbal medicine you're trying to develop. So that is what we can look at, the use or application of this chromatography in separating, purifying, identifying, and quantifying components in the sample mixture. These ones are found in the sample mixture. And this, it is being applied in different fields whereby it is being applied in pharmaceutical chemistry labs, where there is developing of drugs. We are applying it in forensic medicines to identify drug addicts. Maybe people who use marijuana, cocaine, we can easily analyze using chromatography, and we find those toxic drugs in someone's urine or blood. We are using it in the food industry, in the cosmetic industries. All these are applying chromatography to identify compounds. In the food processing industry, we can use chromatography to identify if there are certain toxins or chemicals in food that might be harmful to man before being released on the market. The same thing in pharmaceutical, whereby we're using it to purify drugs, to identify if drugs contain toxic substances, to remove impurities, and also to determine the chiral center of these drugs and their interaction. Then in cosmetics, we are using it to separate different dyes which can be used. So this is the application of chromatography, which we are looking at as the physical technique. And what are the components? What are the components? That is our objective number 3. Components. And here we are looking at the general components of chromatography. And this chromatography, it contains components: 1, sample mixture; it contains mobile phase. We have the mobile phase. We have the stationary phase. And we have the detector system. So these are the 4 general components of chromatography. And the word chromatography comes from 2 Greek words: chrom, which means color, and graphe, which means writing. So it was previously known as color writing. But of these days, it has been modified. So under the components, we have sample mixture, and this sample mixture containing different analytes, or you can call them different compounds, which are to be separated, purified, or identified. So this is the sample mixture, and it is always injected into the mobile phase, whereby the mobile phase, as we are seeing it as the second component, it can either be a liquid, and when it is a liquid, we call it solvent. So, and it can also be a gas. So these 2 components of the mobile phase, its other name, we can call it eluent. This is the eluent. It is the one that transports or moves the sample mixture to the stationary phase. So we can transport the sample mixture containing different analytes to the stationary phase using the eluent, which we call the mobile phase. So it is always moving the sample. And this mobile phase can be either liquid or a gas. And we shall see also classification depending on the physical nature of the mobile phase, which can either be liquid chromatography or gas chromatography. Then when we go to the stationary phase, which is the 3rd component, with the stationary phase, here the word stationary means static. So meaning this phase, it does not move. It is stationary, or it is placed in one place without moving. And this stationary phase, it contains also substances which can be either solid or liquid. And these substances are always immobilized in a column. So they are always immobilized in what we call a column. And as this sample mixture is being brought by the mobile phase, it will depend on the interaction of the analytes in the sample with the stationary phase. And those ones which has high affinity for the stationary phase will move slowly compared to those which have less affinity to the stationary phase, as we shall see different mechanisms like adsorption, like partition, size exchange, ion exchange, and affinity. So it will depend, and this one we are also using it to classify different chromatographic methods. Last here is the detector. Detector, this is the detection system. It is the one we are using to identify or visualize and quantify different components in the sample or compounds. And the different detectors we can use, among the detectors we can use UV spectroscopy. This is for quantitative. We can use infrared spectroscopy. We can use fluorescent dye, whereby we can visualize using fluorescent microscope. We can use compounds like iodine to stain. Iodine, for example, when we are dealing with carbohydrates, we can use ninhydrin when we are dealing with amino acids. We can use potassium permanganate when we are dealing with organic compounds. All these can be used as detector system either to visualize or quantify the amount of the analyte within the sample mixture after being eluted via the stationary phase. So these are the components we can talk about. The next thing is classification. How can we classify different chromatography methods? So we are looking at the classification of chromatography. How are they classified? And we are saying we are classifying them in 3 ways, whereby number 1 is on the basis of the physical nature or physical state of the mobile phase. Physical state of the mobile phase, whereby the physical state or nature of the mobile phase, it can either be a liquid or it can be gas. So we are going to see different types of chromatography, whereby we have liquid chromatography, and an example of liquid chromatography we can give is HPLC, high performance liquid chromatography. We are going to see gas chromatography, which can be gas solid chromatography or gas liquid chromatography, whereby the mobile phase is the gas, but the stationary phase can either be a solid or a liquid. We shall also those different types. Then the second basis of classification is according to the chromatography bed. So we can classify according to the chromatography bed. Chromatography bed shape. This chromatography bed shape, we can call it like a column. So under this, we are going to see, we can classify them. They can either be 2-dimension or they can be in 3-dimension. 2D is a substance which has only length and width, whereas 3D, it has length, width, and height. So with the 2D, 2-dimensional chromatographic bed, we have what we call paper chromatography. Paper chromatography, and we have thin layer chromatography. So these are the two types which are 2D. They have length and width, whereby under thin layer, we are using a glass or a plastic plate which has length and width, and we are putting the adsorbent molecule, such as silica gel, alumina gel, or cellulose. That's why we are calling it a 2D. Then with paper chromatography, we are using a filter paper, which has also length and width. And we are using them to separate dyes and other sample mixtures depending on their movement in the stationary phase. And we shall be able to measure their what we call retention factor. Then 3D, the example is the column chromatography. And examples of column chromatography still, we shall see HPLC also belonging here. As it is the liquid chromatography, but still it uses column, which is a 3-dimensional, having length, width, and height. So that is another class of chromatography. The last one, which is the third, is on the basis of mechanism. It is mechanism on how samples are separated, sample mixtures. And this mechanism depends on how molecules interact, how analytes interact with the stationary phase. So examples, we are going to see examples like we are going to see adsorption chromatography. We have partition chromatography. We have ion exchange chromatography. We have size exclusion chromatography. And lastly, we have affinity chromatography. So this is classification depending on the mechanism of separation, how these solutes or analytes interact with stationary phase. Under adsorption, it works under the principle of polarity, whereby the like attract like, whereby polar molecules are attracted to polar column, whereas non-polar are also attracted to non-polar. So this one depends on the polarity, whereby the like attract like. Those who, if we are using polar substances in the stationary phase and the material in the mobile phase is also polar, there will be much interaction and less and much retention time, as we shall see. Then with the partition, it depends on the solubility. This partition deals with liquid to liquid, whereby you have volatile and non-volatile liquids, and we want to look at their solubility interaction. Those which are soluble, they are retained, they have much retention time in the stationary phase. Then those which are not soluble have less retention time. Then ion exchange, this is dealing with ionic compounds or ionizable compounds, which can either be negative, they can be positively charged or negatively charged. So we shall be depending on the charge of the stationary phase and the charge of the sample mixture, the analytes in the sample mixture. And hence we can easily see their interaction, and different compounds interact differently, and we are able to separate them basing on their interaction. Then size exclusion, whereby the stationary phase contains powers. These powers in like HPLC, they are between 2 to 10 micrometer. So these ones depend on their power size. And we see that analytes which are small in size they pass through the pores and take longer to move via the stationary phase. Whereas those with the big-sized analytes, since they do not enter into the pores of the stationary phase, they pass through faster, hence they have less retention time. Then affinity, this is whereby the stationary phase is containing some antibodies which have specific receptors, and we shall see interaction of analytes basing on their love to bind to the receptors or to the antibodies which are immobilized in the stationary phase. That is what we shall look under this classification. So after understanding classification, basing on the physical nature of the mobile phase, basing on the chromatographic bed shape, and basing on the mechanism or the interaction of the solutes with the stationary phase, we are going to end by looking at some of the definitions or terms used in chromatography. And one of the terms is, we are talking about the sample mixture, we are talking about of the solvent, we shall talk about of the mobile phase, which we have defined, and the stationary phase, which are already defined. We shall look at the retention time. You can talk about retention volume, you can talk about retention factor. Then we shall go ahead to talk about some other terms used in chromatography, such as eluent. Then we have eluate, we have elution, and many others we shall say. So what is a sample mixture? A sample mixture, this is the one that is containing different analytes to be separated and identified, which is always injected or added to the mobile phase. Then solvent, this is used to dissolve solutes, and it is majorly a liquid. So if we have the sample, we put it in the mobile phase, which is a liquid, to dissolve the solutes. Whereas the mobile phase, we said it can be a liquid or a gas, which moves or transports the analytes. Then the stationary phase is the immobile phase, which the mobile phase brings the analytes to be separated depending on these mechanisms. Whereas the retention time is the time taken when the sample is added to the mobile phase up to when it reaches the detector system. So the time between the sample after being added to the mobile phase, the time it will take to reach the detector system. So this time lag is what we are calling retention time. Whereas retention volume is the amount of the mobile phase, the amount of the solvent in the mobile phase we need to transport this sample from the point of application up to the detector system. That is what we call retention volume. It is the volume or the amount of the solvent in the mobile phase required to move the sample analyte from the point of application to the detector system. Then retention factor for it is the ratio. Retention factor is the ratio of the distance traveled by the compound over the distance traveled by the solvent. This is how we are able to calculate the retention factor of different compounds in the sample mixture. Then what is eluent? Eluent, this is the solvent which we are using in the mobile phase to transport the sample analytes. Then eluate is like a product which we get after passing the mobile phase via stationary phase. So if, for example, if this is the stationary phase containing different materials, and I bring the mobile phase, what will come out of the column to reach the detector is what we are calling the air weight. So air weight is like a filtrate which passes through the stationary phase. Then the elution is the process. The process of passing the mobile phase containing the sample analytes into the stationary phase and being separated depending on their interaction. That is what we are calling elution. So these are the things we can talk about. Another term we shall look at is the chromatogram, whereby chromatogram is the graph, which is the plotted graph. After the detector has done, it comes out with a graph which we call a chromatogram containing different peaks, and each peak portraying a different compound which has been separated. So this is what we can discuss with you in this introductory video. Stay tuned as we take you through different types we have seen here, that is high performance liquid chromatography, gas chromatography, column chromatography, thin layer. They are going to be series, and we shall also take you through calculations on how we can determine the peak size, the retention factor, the retention volume, the column coefficient. All of them we shall look through. Thank you so much. Remember, please to like if you have enjoyed this video and share to many others. May God bless you.